Alrighty, so due to the time constraint of our class, and I'd rather focus our class on doing examples, I will derive the following logarithmic properties in the change of base formula for you here. Alright, so the first property is the product property of logarithms. It states, so b, x, and y are all positive real numbers where b does not equal 1. This applies to all the logarithmic properties. Right? But the product property states that log base b of x times y is equal to log base b of x plus log base b of y. So if the argument, if it's multiplied, then we can separate them. Right? So how do we get it? So proof. Right? So we're going to let m be log base b of x, and we're going to let n be log base b of y. Okay, so m is equal to log base b of x, so this implies, so this can be rewritten. So recall if we have y is equal to log base b of x, it is equivalently written as b to the y is equal to x. So equivalently, this is written as b to the m is equal to x, and over here this is equivalently written as b to the n is equal to y. Okay, so observe. Okay, if we have x times y, okay, what is that? That is going to be b to the m times b to the n. Okay, and by the exponential properties, this is equal to b to the m plus n. Okay. And again, so just like what we did here, we rewrote this in the exponential form. What I'm going to do now is I'm going to rewrite this in the exponential form, but we're going to go this way. Right? So what is this equivalent to? This is equivalent to log base b of x times y is equal to m plus n. Oops. Okay, but recall, what is m? M is log base b of x, and n is log base b of y. Okay, and that is how we get the official, and that is how we get the property. So I'm going to rewrite it just to be all on one line, so that means we get log base b of x times y. This is equal to log base b of x plus log base b of y. Right, and that is the proof. Now what I'm going to do is now we're going to prove the quotient property. Okay, so let me add some space here. Oops. Ah, crap. Put on the wrong spot. Alrighty. Let's get started. So, again, what we're going to do is we're going to do something similar. Okay, so we're going to let m equal log base b of x, and we're going to let n equal log base b of y. Okay, so this is equivalently written as b to the m equal to x, and this is written as b to the n is equal to y. Above we did x times y, but what we wanted, our goal is to show the quotient. So what we're going to do is we're going to observe, okay, x divided by y. Okay. What is this equal to? This is equal to b to the m over b to the n. But by our exponential properties, this is going to be b to the m minus n. Okay, so I'm going to rewrite it just so we can see what we're dealing with. So we have x over y is equal to b to the m minus n. And again, I'm going to use this equivalent property, but I'm going to make this into logarithmic form. So this is going to be log base b of x over y. This is equal to m minus n. But remember, what is m? M is log base b of x, and our n is log base b of y. So therefore, let me add more space here. Therefore, that's what these three dots mean. Log base b of x over y, this is equal to log base b of x minus log base b of y. And that's how you derive the quotient property of logarithms. Right. The final property of logarithms that we will be talking about is the power property. Okay. So again, similarly, okay, if you notice, we only have one logarithm, so I'm just going to focus on m. So we're going to let m equal to log base b of x. Okay, this can be rewritten as b to the m is equal to x. Right. Since we're talking about the power property, and then and then p is any real number. Right. So we want to consider, or yeah, I used observe before, so I can change up my wording. So say consider. Okay, we're gonna look at x to the p. Okay, but what does x? X is b to the m. Okay, to the p. Right. So this is rewritten as, so again, as for the exponential properties, this is b to the m p. Again, I'm going to rewrite it so we can clearly see what we're dealing with. Okay, x to the p is equal to b to the mp. This can be rewritten as log base b of x to the p, and then this is equal to m times p. Right? But again, what is our m? Our m, so yeah, I'll just do it this way. Sorry. Okay, m times p, but multiplication is commutative. I'm going to rewrite this as p times m. It's just going to look better. Okay, so it's going to be p times, and then log base b of x. Okay, so therefore, log base b x to the p is equal to p log base b of x. One note I have here is when you do the power property, so if it's written like this, that's perfectly fine. What it just means is that this p is attached to the x. We can apply the power property here because p is part of the argument, but we cannot apply if this is like log base b of x, and let's say this is to the k. Okay, this is not equal k log base b of x. Okay, the reason why is because this is going to be log, so since this is to the k, it's going to be log base b of x times log base b of x times ... times log base b of x, and this is going to be k times. Okay, so just make sure, first of all, don't write the parentheses wrong because then you're going to have totally different meanings, but also be careful when you do read a problem, if it's like this, okay, you cannot use the power property. Right. So now what I'm going to do is we will now talk about the change of base formula. Right. So the change of base formula, so a does not equal 1, b does not equal 1. But remember, they also have to be greater than 0. All right. So how are we going to prove the change of base formula? Okay. So we're going to let y equal to log base b of x. Okay, and again, this can be equivalently written as b to the y is equal to x. Okay, so yeah, so then I have, so b to the y is equal to x. Okay, what I'm going to do now is I'm going to multiply both sides by log base a. And then this becomes, so this is going to be b to the y is equal to log base a of x. The reason why, so these parentheses aren't needed, but the reason why I'm putting them is just to show you when you take a logarithm of something, like this whole thing becomes an argument. So if I took if I had x squared plus 5 minus, or 5x minus 2, if I took the logarithm of this, then this would be log of a, and then x squared plus 5x minus 2. Okay, this whole thing becomes the argument. right? So if you omitted the parentheses, that's not right, because I would just assume that you're just saying log base a of x squared, okay, that whole thing, and then plus 5x minus 2. Okay, and that's not right. Going back to our problem, okay, so now what I'm going to do, since this exponent is in my argument, I can apply the power property. So this becomes y times log base a of b. This is equal log base a of x, okay, by power property. Okay. So I guess I should have told you, our goal is to solve for y. Okay, so now what I'm going to do is I'm going to divide both sides by log base a of b. So this is going to be log base a of x divided by log base a of b. Okay, and then we never have to worry that log base a of b is ever 0, because as you can see, b can never equal 1. And so remember, the only time a logarithm is 0 is if I have log base b of 1. Okay, because then you'll get b to the y is equal to 1. The only way this equals to 1 is if y is equal to 0. Okay, so that's the only time that it can equal 0, but luckily, because of this, it cannot. Okay, so this is how you get, oh, sorry, I'm not even done. So, but remember, what is our y? Our y was log base b of x. So therefore, we have log base b of x is equal to log base a of x over log base a of b. Okay, and that's how you get the change of base formula. And this also shows, so a can be any number. You could actually, so if you had like log base 5 of, I don't know, 2, okay, this, you could make it any base you wanted. You could make a equal 3. You could say log base 3 of 2 divided by log base 3 of 5. Okay, we could do that. A can be any number as long as it's positive and as long as it does not equal 0, or does not equal 1. Okay, the only reason why we pick, so the two common bases are 10 and e, and the main reason why is because it works nicely with our calculator. Right, so that is it.